Alright, in this tutorial we're going to go over how to write an equation of a linear function when given a graph that's completely plotted out. So, this first example right here is a linear equation, and the two things that you need to identify in order to graph a line are the slope and its y-intercept. Once you can identify those two things when looking at the graph, then you're able to write your equation. Now the y-intercept is the point where the graph crosses your y-axis, which is this line right here, the y-axis. So the graph crosses at this y-axis right here at this point, which is -2. So that's what your y-intercept is going to be. Oh boy, that color is really bad on the white background. -2. Now to get your slope, it's much easier to remember how to calculate slope when you are moving left to right. So to go from this point to our next one, which is right here, we are moving down 1 and over 1, 2, 3, 4, 5, 6, 7. Over 7. So our slope is -1 over 7. Now, given those two pieces of information, we're going to graph it in our y equals mx plus b form, since we want our equations in slope-intercept. Our slope is the -1 over 7, and our y-intercept is a -2. So you just plug those two pieces of information into your mx plus b, and that's how you graph it in a function form. Same thing with the other one. We're going to go to our y-axis, figure out where the graph crosses, boom, right there at -4. Then we got to figure out the slope to get to our next point, which there's going to be one right there. So to count, we're going to go up 1 over 1, 2, 3. So our slope is up 1 over 3. So then the same exact type of equation, y equals mx plus b, plug in your m or your slope, and then plug in your y-intercept. And that's it. One thing you may need to be aware of is if you are counting your slope to make sure that it's completely reduced, but if you are going from one point to the exact next point, it should already be reduced. But let's say, for example, we were going from this point all the way to up here. That would have been up 2 and over 6. So the slope would have been 2 over 6. That fraction must be reduced. And the way you reduce it is to divide by 2 to get 1 over 3. So if you're counting to the next exact point, your fraction should already be reduced. But if it's kind of hard to read the graph and you end up skipping one to get to your next point, just make sure that your slope fractions are completely reduced. Your y-intercepts, just make sure that you're plugging the exact sign of what you see from there.